Hello and welcome to SudoKanard. We're here to solve this XM Sudoku that I created for the recent WPF Sudoku Grand Prix. And XMs is one of my favorite arithmetic variants. And with 46 points, I think it was a little undervalued. I would have given somewhere between 50 and 55 points, but well, who am I to just decide? So I was quite happy to have this visual theme, not so visual as arithmetic theme, with arithmetic sequences with how is it with a difference of 5. Well, it doesn't work for those ones, but there was the symmetry and very few clues after all. So the special rule of X sums is that this is the sum of the first few digits, and how many digits are to be taken into account is just given at the start of the row or the column. So 5 can only be made with 2 digits, which are 2 plus 3. So 2 here to say we sum the first 2 digits, and the second digit has to be a 3. And I will just use this coloring to tell me that this clue has been used to its full potential. 10 will need now at least 3 digits and at most 4. 4 would work with 4, 3, 2, and 1. And 3 digits could work with, say, 3, 6, 1 or 3, 2, 5. 15 could be as many as 5 digits from 1 to 5. It could also be 4, it could also be 3. 20 could work with as few as 3 clues, with 8 and 9 here, except that this wouldn't work because now this 12 could never be done. Where 2 digits wouldn't work, we would need at least 4 digits, but with 4 digits and this digit, that would be way too much. So 3 digits would never work here, but 4 could work, 5 could work. Actually, I think that 5 here wouldn't work, but it's probably too soon to decide on that. I will go with 6. 6 could be as many as 3 digits, but in this case we would have digits 1 and 2 here, and none of them would work with 31, obviously. 31 is much too big. So the only possibility is to have 2 digits, and the second digit is a 4. 11 now can only be the sum of 3 digits. Actually, 4 digits would not even work. That's something you have to check. The only way to have 11 be the sum of 4 digits is 1, 2, 3, 5, and this does not include digit 4. So it has to be 3. 2 is not available. So those 2 digits must sum to 8, and without those digits, the only way is to have 1 and 7. So this 6 is satisfied, this 11 is satisfied as well. So this 16 could be 4 digits, and actually 5 digits would not work, because there again, 5 digits summing to 16. This is something that is familiar to people who do a lot of kakuro or a lot of kira sudoku. 16 with 5 digits is 1, 2, 3, 4, 6, which doesn't use the 5. So only 4 is possible here. Now, we must have 3 digits summing to 12. There are loads of possibilities for that, so I won't try to pencil mark this. 21 could be 5 digits. It could also be 6 digits if you use all digits from 1 to 6. 26 could also be 5 digits. It could also be 6 digits, but it could not be more than 6 digits because the minimum sum you can have with 7 digits is 28. So at this point, we can't rule any of those out. And you can see that this here is an 8 or a 9, which is probably not that useful. So 31 here can only be 5 or 6. Oops, not here. 5 or 6 here. And where should we look? Perhaps this 25. 25 Well, 5 is not available. It could still be 5 digits or 6 digits. And at this point, so we know that only 3 will work here. And knowing that this is 3 and knowing that the sum of all digits in the column is 45, we know that 42 is the sum of all other digits, so that this is 8. And this is now fulfilled. And actually 19 will be fulfilled once I notice that those two digits must sum to 16, which is only achievable by 7 plus 9. And seeing this, 7 goes here and 9 goes there. So now 7 and 9 on this row must go into those cells. And those here are 1 and 8. And I can see that 2 goes somewhere here because of this 2. And those digits here are from 4, 5, 6. That doesn't seem so useful to pencil mark it, but I'm doing it anyway. So where is the next place to look? Well, probably this 12, or perhaps this 17. I mentioned earlier that the sum of all digits in the column should be 45. And here we have 17 and here 31, which is a total of 48, which means that the digits spanned by this sum and the digits spanned by this sum must overlap with an overlap summing to 3. So the overlap should be 1 digit 3 or 2 digits 1 and 2. So this plus that should be either 10 or 11. So 10 could be achieved with a 4 and a 6 here. 11 would be with this and a 5 or 6, which doesn't work. So the only way of doing what I just mentioned is to have a 4 here and a 6 there. And the overlap is this single digit, 4 cells here, 6 cells here, and this has to be a 3. So now we have 7. Those two digits must sum to 10, which at this point can still be 1, 9 or 2, 8. So this is not resolved yet. But I really liked this logic. So this 6 turns this into a 5. So we know that those 5 digits sum to 25. So those 4 digits sum to 20. So 12 is the sum of at most 3 digits, because 5 digits make 20. So this is at most 3, and it can't be less than 3. So this is actually a 3. Those two digits now must sum to 9. It's not a 3, it's not 4 plus 5. It must be 1, 8 or 2, 7. I can't decide about this at this point. Oh, this 3 here is interesting now, because this is no more a 3, and this is no more a 5, because 5 here would need those digits to include a 3. It would be 1, 2, 3, 4, 5. So this is finally 4, this is 5, and this is 3. And those two digits sum to 7. They must be 1 and 6 or 2 and 5. But now let's ponder this column. So this is 12, and I mentioned earlier that this is 20, so this has to be 8. And this is interesting because those 4 digits sum to 15, those 2 digits sum to 12, so those 2 digits must sum to 3. There must be a 1 and a 2, which means that this 15 is now done. And then what? So those must be either 1 and 6 or 2 and 5. Or perhaps I should focus on that. Yes, I should focus on that. I mentioned earlier that those two digits sum to 9, and they had to be either 1 and 8 or 2 and 7. There are no more 1 and 8, so they must be 2 and 7. And now, because of this, the option 2 and 5 here is no more a possibility. 5 is here, 2 is here. So this has to be a 1 and 6, which means that this is 2, this is 1. And this then here is now basically done. And then what? So here we have 5, 7, and 9, but 5 and 7 are here, so this is 9. And because of this 5, this is 7, this is 9. No, sorry, this is 5, this is 9, this is 7. 1, 6, and 4 around here. This is not 1. And I need an 8 somewhere in here. So now 25 and 12 must be done. Yes, they are. Here I need an 8 somewhere. This column still needs 1, 8, and 6. This is not 8. This row is interesting. I know that this has a sum of 16. Here I have 21, so that's a total of 37. I still need 8 here. Without using those digits, they must be 2 and 6. Oh, and by the way, this one here turns this into an 8, and that's a 1. So that's 2 and 6, and those 3 digits now, they must include a 3. 3 is not here, so 3 is here. And those are 1 and 8. And the 16 is now done. Those ones here tell me that there's no 1 here, so that's a 1. Those digits, 8 is not here, so 8 on the column must be here. Those here are 2 and 5. No, sorry about that. There are 5 and 9. So 5 is never here. And this is 1. And this is 6. And this is 1. I could probably have solved this earlier, resolved this. There's probably a better way of phrasing it. Here I need 7 and 9. And 2 is not here. This is from 3. No, sorry. Those 3 digits are 2, 5, and 6. Well, 6 here tells us that this is 6, and this is a 2, 5 pair. So now we need a sum of 10 here, and 1 is not available, 3 and 4, so this has to be 2 and 8. So this is 1, this is 8, this is 5, this is 2, this is 9, this is 5, this is 7, this is 1. There again, I could probably have found this earlier. This 17 and this 31 are now done, and those clues at the bottom will serve to disambiguate the lot. This row still needs 5, 7, and 9. We have 7 and 9 here. This is 5. This is from 7, 9. I don't know in which order. I need an 8 somewhere here. It can only be here. 7, 9, and 4. 7, 9 here, so this is 4. This is from 7 and 9. This column needs a 1, so that's the 1. And this is from 2 and 6. But I'm seeing that this row, because of those 2's, 2 must be somewhere down there. So this is 6. This is 2, this is 6. That's 4, that's 6. That's not 1. 1 at the in this column must be here. All right, so here I need 3, 7, and 9. And is there anything I can say? So how do we disambiguate that? Oh, perhaps this 20. Yes, this 20. So this is 20. So the remaining 4 digits must sum to 25. And there's a 1 here. So those 3 digits should need to sum to 24, which is only achievable by 7, 8, 9. So that's 8. That's not 3. That's 3. That's 2. That's 7. That's 2. And this is also 7 or 9. And here we have 3 and 4. So that's 4. That's 3. All right. So this 20 is now done. And there again, I could probably have solved this earlier. And what can I see? What I'm seeing is that now 21 with 5 digits is not achievable. If I put a 5 here, that's 10, that's 11, and this would have to be a 10. So that's 6 digits. Finally, that's 5. So this 6 means that this is 8, this is 6, this is 8. And now knowing that those 6 digits sum to 21, those 3 digits must sum to 24, which means that this is 9, and this is 6. These 5 digits sum to 26, so those must sum to 19. Here I have 10, and this is now 9. And the rest should be just Sudoku. 7, this is 2, so this is 5, this is 2, this is 5, this is 4. And this completes the solve of this puzzle. And, I would just add some last-minute coloring, just for the sake of completion. And this video has been much longer than most previous videos with puzzles that were worth much more than 46 points. And that's the reason I think this was undervalued. Of course, I may have had to give much more explanations, many more explanations than in the previous videos, and this could explain that this video was longer. But I think the difficulty in itself was higher than in, say, well, perhaps not skyscrapers. But I think the difficulty is much higher than in the next videos, in the next few videos with puzzles that are worth 45, 44, and 43 points. Well, that's it for today. Thanks for watching this video, and see you soon on SudoKanard.